Hello, everybody. I'm now going to show you the p-value method for conducting these hypothesis tests that I illustrated uh, via the critical value method. And so the first one will be the two-tailed tests involving the survival rates of cardiac arrest patients for the day versus the night. Um, and of course, these were the hypotheses that we were testing. The claim was that the survival rates were the same for the patients who suffered cardiac arrest during the day versus the nighttime. And the alternative hypothesis says that the survival rates were not the same. Of course, when we conducted this hypothesis test showing all 5 steps, the critical value method, we seen that we were able to reject the null hypothesis and therefore conclude that the claim was not being supported by sample evidence and that survival rates of cardiac arrest patients were not the same between daytime and nighttime occurrences. We're now going to conduct this test over again, but this time we're not going to show all 5 steps. We're just going to use our calculator and conduct what's called the p-value method. Um, and to do this test on the calculator, we are going to be using the function called 2prop-z test. So what we do is we bring up our calculator here. And what you do is you hit stat, go over to tests, and go down to 2prop-z test. So stat test 2prop-z test. Hit enter to activate the test. Now, remember, sample 1 consists of the daytime cardiac arrest patients, whereas sample 2, or population 2, consists of the nighttime cardiac arrest patients. So x sub 1 is going to be, let's see, x sub 1 will be 11,604. 11,604 cardiac arrest patients during the day survived of 58,593 that were surveyed during the day. So we type in 58,593. Population 2 are the cardiac arrest patients at night, and 4,139 of them survived cardiac arrest that occurred at nighttime. Of the 28,155 patients that were randomly surveyed, 28,155. This is a two-tailed test, so we select not equal to, and we just go down to calculate, and we're ready to conduct this hypothesis test here. So we hit enter to calculate, and of course, we get our output. Now, how to interpret the output here? Well, notice that the 18.26 blah, 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 that's our test statistic value that we computed manually when showing all 5 steps. Please check back with your notes. But the most important number on this entire screen, ladies and gentlemen, is the p-value. And notice our p-value is extremely small. It's 1.811 times 10 to the negative 74th power. And so this p-value essentially is like very close to 0, if not 0. And therefore, we would reject the null hypothesis without any doubt whatsoever. This is an extremely conclusive test because we have such a small p-value. Remember my saying, for p small, reject the null. And so therefore, we're going to reject the null hypothesis. And this supports the conclusion that we were able to um, go with when we did the problem using the 5-step method or the critical value method. And so therefore you can see that the claim is not being supported, that survival rates of day and nighttime cardiac arrest patients are not the same. So that's how you conduct a test using your calculator, the so-called p-value method. All right, now let's take a look at the second problem that I demonstrated, showing all 5 steps to critical value method. This is the lower tail test. And this involved the infants in Kenya, Africa, who used bed nets versus did not use bed nets to try to reduce the infection rate of malaria carrying mosquitoes. And notice that when we did this problem the manual way, the critical value method, by illustrating all 5 steps, we were able to reject the null hypothesis and therefore go with the alternative hypothesis as being a truthful statement, which indeed did show that the proportion of, uh, of infants who contracted malaria was less for infants that used bed nets than those that did not use bed nets. So let's now do this test using our calculator. And of course, to do this test, we will use the 2prop_z test function. So again, hit your stat button, go over to tests, go down to the 2prop_z test function, hit enter. And now we need to type in our sample evidence. And notice we designated population 1 as being the infants that did have bed nets, and population 2 as those that did not have bed nets. So of the 343 infants surveyed that had bed nets, 15 contracted malaria. So x sub 1 therefore is going to be 15. N sub 1, sample size 1 will be 343. And of the 294 infants that did not use bed nets, 27 contracted malaria from mosquitoes. So x sub 2 would be 27. And the sample size 2 is 294. Of course, this is a lower tail test since our alternative hypothesis statement has less than, so we select less than. We're ready now to conduct this test. So go down to calculate, and here we go, ladies and gentlemen. Boom, there's your results. Notice our test statistic value, about negative 2.44, was computed manually using the critical value method. Check your notes. But the most important number on the screen, of course, is the p-value. And notice the p-value is 0.0074-ish, and that's a very small p-value. It's definitely less than 1%, 0.01, and so therefore, since our p-value is less than our level of significance alpha, we're going to reject the null hypothesis and therefore conclude that it looks like the claim is being supported. The claim being that, yes, it looks like the proportion of infants that contract malaria is less for those that use bed nets as opposed to not using bed nets. And so therefore this concludes, basically cooperates with our decision that we were able to ascertain using the 5-step critical value method. And so this is how you do the p-value method using the 2prop_z test function on your calculator. All right, I will post one more video that will go over a couple more examples of hypothesis testing involving 2 population proportions, and also show you how to build some confidence intervals for the difference between the population proportions. So make sure you do look at those videos.